In this video, we're going to go over graphing quadratic equations in Vertex form by plugging in some points. So the first thing we want to do is find the vertex, and the vertex is HK, which in this case is 5, 7. So that would be 5, 1, 2, 3, 4, 5, 6, 7. The vertex is right there. It's also helpful if we draw in our axis of symmetry. A lot of times it's just drawn in with the dashed line because it's not actually part of the graph, but it does help us as we are going to graph our parabola. And then from there, we need to find some points on either side. The nice thing is I can choose points on either side of my axis of symmetry and know that wherever one is, I can just reflect its counterpart on the other side of that axis of symmetry. So really, if my axis of symmetry is at 5, plugging in 4 and plugging in 6 would give me the same number. Plugging in 3 and plugging in 7 would give me the same number. So depending on where your axis of symmetry is, it will always vary for each question. I like to choose, positive numbers over negative numbers if it's doable. In this case, I like to plug in the smaller values as opposed to the larger values. So you always want to choose some points that are around your axis of symmetry, but always try to pick the easier one and then just reflect it to the other side. So I'm going to plug in 4 and 3 into my equation and see what happens. So if x equals 4, it would be negative 3 times 4 minus 5 squared plus 7. And I'd have to evaluate that. So parentheses first, 4 minus 5 is negative 1. Then I need to square that. So that would be negative 1 times negative 1, that's 1. Negative 3 times 1 is negative 3. And negative 3 plus 7 is 4. So when I plug in 4, I get a value of 4. So that would be right here. And now that I know that point, I've reflected over the axis of symmetry, and I know that point as well. Now I want to plug in x equals 3. So negative 3 times 3 minus 5 squared plus 7. 3 minus 5 is negative 2. Next is exponent. Negative 2 squared is 4. Negative 3 times 4 is negative 12. And negative 12 plus 7 is negative 5. So at 3, the y value would be negative 5. And now, once again, I can take that, reflect it over my axis of symmetry to figure out that point. I can see that because my a is negative 3, those values are jumping up very quickly, or I guess jumping down very quickly. So I don't think there's going to be any more points that fit on my graph right now. So you always just want to plot as many points as you can that are going to fit on what's available. It might not be that many points. So now that I kind of can see the general shape of my parabola, I'm going to take this and try to connect them, try to make it a curve and not a point so it doesn't look like absolute value. Make sure you put some arrows at the end. And that is how you are going to graph by plugging in points. So once again, we found the vertex. We drew the axis of symmetry. And then we just chose a couple points to plug into that equation to figure out its corresponding y values. And once you have one point, you can always just reflect it over to the other side. Okay, let's do one more together. Okay, here it's 1/3 x squared. There is no h and k. So in this case, our vertex is at 0, 0. And I don't really need to draw in my axis of symmetry because the y-axis is just acting as our axis of symmetry in this one. But we need to plug in some points. Now, because it's 1/3 x squared, it's going to be helpful to choose certain values. And because whatever we're plugging in here, we want to take 1/3 of it, it's going to be helpful to plug in multiples of 3. So if I plug in x equals 3, that would be 1/3 times 3 squared. Exponent first, so 3 squared is 9. And 1/3 of 9 is 3. So our first ordered pair would be 3, 3. Okay, which means if reflected over, that would be over there. And then if I want to do another one, I would say 6. So if x equals 6, oh yeah, that's already not fitting. Because that would be 1/3 times 6 squared, and 1/3 of 36 is 12, and that's not going to fit on my graph. But I can estimate. So 3, 4, 5, 6, 7, 8, 9, 10. So it's going to be something like that. And then connect. Okay, I probably should have given myself a little bit more space there to graph another point. But 6, 12 would be a spot we could graph. Okay, and then connect, put your arrows, and then you have your parabola. Okay, so once again, vertex, draw in your axis of symmetry if needed, plug in a couple x values to find the corresponding y, and then graph it on either side of that axis of symmetry.